Hi guys, this is the second question of biweekly contest 185. In this question, we are given an integer array lights. Now the question says, if the value of light I is greater than 0, a bulb I illuminates max of 0, I minus b to minimum of n minus 1, I plus b. Basically it is saying if the value of light I is greater than 0, then it will illuminate till I position backward to I position forward, but it should remain in the boundary of 0, and minus 1. Basically, for example, if the light size is 0 to 7 and the light at position 1 light I value is 2, so it will illuminate till 1 comma minus 2 position, which will become minus 1, which is also of boundary, so we will not go till minus 1. We will start from 0. So we will start from 0 and it will illuminate up to 2 position forward, which is 2 plus 1 3. So it will illuminate total 0 to 3, since value of 1 is 2, light 1 is 2, and if the light I is 0, then it will not illuminate any position including itself. Now we can add some additional bulb as we require, and if we add the bulb at position J, then it will illuminate total 3 position: itself, previous position J minus 1, and the next position J plus 1. Now we have to return minimum extra bulb needed so that every position is illuminated. So we have to tell how minimum number of bulb we need to add. So as it is given, a new added bulb at position J illuminates J minus 1, J and J plus 1. Basically it is going to illuminate total 3 position. So if position I is dark, if position I at some position it is dark, then where we going to put the bulb? We are going to put it I plus 1. Why? Because position I, consider I minus 1 is illuminated. Okay, so position I is dark. I am going to show it. Okay, in this example, in the example 1, we will see that we have put the bulb at position 2. So it has eliminated position 0 to 4. Now we have found the position 5 is dark. So where we are going to put the bulb? We are going to put at 6, because it is going to eliminate total 3 position. So for the maximum benefit, we are going to point it 6. So if we put it here, then it will illuminate total 3 position: 5, 6 and 7. It will illuminate total 3 position. But if we put it 5, then what will going to? It will going to illuminate only 2 position, 5 and 6, which is not benefit. Again 7 is dark, and again we have to put the bulb at 7. So in this case we have used 2 bulb, while we can get the benefit from 1 bulb only. Similarly, in the example 2, there is bulb already at position 2 and position 7. So it will eliminate the position 0 to 4, and it will eliminate the position 6 and 7. So where we are going to put the bulb? We are not going to check if 6 is already eliminated or not. We are just going to do, we see the 5 is dark, we are going to put our bulb at 6, and we say it has eliminated the 3 position 5, 6 and 7. It is not a problem if the same position is going to illuminate by 2 or more bulbs. The only problem is it should be illuminated, it should be brightened, it should not be darkness. So what we are going to do, we found the darkness at position 5, we are going to put our bulb at position 6, and we are going to brighten 3 position 5, 6 and 7. And we are going to solve this question at n of n time complexity, and O of one space only. Sorry, of n time complexity and O of n space complexity. Okay, what we are going to do? We are going to create a array which is going to point out from which position the illumination is start and up to which position it is illuminated by a particular bulb. We will use the prefix sum, which will we have to find out from how many bulbs this particular point is illuminated. If it is greater than 0, then there is no problem. If it is 0, then there is darkness there. So we will add bulbs if we found the darkness at position I plus 1, and we will return our count. As in this example, the bulb is pointed to position 2, position 3, and it will illuminate till 1 to 4. So what we will create an array just one greater size up to 5. So what we are going to do, we are going to add plus 1 at position 5, because the illuminate is started from index 1 and still it is index 4. So we are going to decrease minus 1 at position 5, because it is illuminated till position 4. So we are going to take 4 plus 1, basically 5. Now we will take the prefix sum. So 0 will remain 0. We will take plus 1, 1 plus 0, 1, 1 plus 0, 1, 1 plus 0, 1, and it is not added. 1 minus 1 will become 0. It will be 0 at position 5. So now here you can see from index 1 to 4, it is 1. From index 1 to 4, all the position is illuminate or brightened by one bulb. Which one it doesn't matter, but it is brightened by at least one bulb. It is not 0, but at position 1, 0, it is 0. So what we are going to do? We are going to add one additional bulb at index 1, and it will brighten 0 position. So now we are going to code n is equals to light dot size, and our answer will be 0, or I will say additional. You can find the code link in description. Now we need an extra vector which is illumination here. Which size is n plus 1 comma 0. It is work as a prefix sum. Now what we are going to do, for int I equal to 0, I is less than n. So now light I will brighten from position minimum of n minus, max of 0 comma I minus b. So we are going to do the same. Illumination change max of 0 comma I minus b. So I minus lights I, it will increase by 1, because illumination is started from this point, and since it will end at minimum of n minus 1 comma I plus v. So again we are going to do the same, minimum of n minus 1 comma I plus v. So I plus lights I. Since this point minimum of n minus 1 comma I minus light I is illuminated, this point is brighter, so we are going to take plus 1, because we are going to decrease that this position from this point, from this index illumination from light I is stopped, and we have to do if lights I is greater than 0. Okay, to make it readable, I think for most people it is difficult to read. I am going to write it more simple as given in question. So I think it is now simpler. So now what we have done, we have set our vector which is saying from which position brightness or illuminate starting and at which position it ended. So now we are going to use prefix sum to mark all the position that this particular point is illuminated by x number of lights. So for n I equal to 1, I is less than n, I plus plus. We don't need the last position, so I taken I is less than n. And illumination change of I will be, we are going to take prefix of I minus 1. Okay, now prefix sum is ready. Now just we need to check which point is illuminated by how many bars. So again for int I equal to 0, I is less than n, I plus plus, int key is equals to minus 1, and if you want to take better for this right coverage. So what is this? It is saying the bulb which I have added at which position till which position it has brightened. The brighten are brighten are error. Brighten are error. So since no bulb is added, I have started with minus 1. So if illumination change I equal to 0, what it means? If this point is not brightened, it is completely in darkness. So will we check if I is greater than for this. I will check that the last bulb I have added if it is covering this point or not. If I is greater than for this add a light coverage. If it is not greater means if it is greater than or it is not covered by the bulb I had added, what I will do, I will brighten this bulb. So our answer is y. Since I have brightened the position I plus 1, so for the rest light coverage will be I plus 2. Why? Because I have added the position or I have added the bulb at position I plus 1. It will brighten the position I plus 2 also. So for this coverage is I plus 2. Now we will return our answer. We will run the test case. Okay, what is it? Unclick answer. Acha, I have changed it. Additional. Okay. Okay, we will run our test case. And yes, test case are passed. We will submit the solution. Yes, our solution are accepted. Please let me know if you have any confusion in this solution. You will find the explanation and code both in description. Thanks to see the video till end.